Okay, you guys are watching a video about dilations.
Video.
What is that? The other creatures too. The arrow tongue resembles the T-Rex and has similar hunting sensibilities. While on the hunt, animators make it look like we're zooming in on his prey, signaling that he spotted something, perhaps some dinner. To create this effect, artists use dilations, making the shape, in this case the prey's body, grow larger, all the while maintaining its shape. For example, look at the arrow tongue's eye. In a dilation, each point in the shape moves along an imaginary line that extends from the center of the dilation, the middle of the arrow tongue's eye, for instance. When dilating, the shape's size changes, but its form remains the same. That's because each point on it changes its distance from the center of dilation by the same ratio. Suppose the radius of a circle, the distance from the center to any point on the circle, is 2 inches. If the circle dilates, the radius of the new larger circle will be larger and will have grown by the same ratio compared with the previous size. That means that each point on it must increase its distance from the center of dilation by the same proportion, doubling. That growth, compared to its original distance, is called the scaling factor. Its new radius of 4 inches is twice as much as the original circle's 2. So, the scaling factor is 2. What would happen if some points change their distances from the center of dilation by different ratios? The shape would be distorted, of course, and we no longer have a true dilation of the same shape. Animators don't want a shape to be disfigured when changing its distance, such as when zooming in. That wouldn't be realistic. They just want the distance to appear to change, using dilations to make that happen. And that's an arrow tongue on the hunt.
One more time.
I think we're good.
What's that thing?
Okay, so that was just showing you an animation and how animators use transformations. Okay. Okay, so in that we learned about the dilation and how you can zoom in and out. Do I need to copy this yet? How we can zoom in and out as far as animation is concerned. And it's a dilation where they stretch, make it all grow at the same proportion or all shrink at the same proportion. Okay. Have you guys ever seen how, like, behind the scenes of how they make like action movies or like the superhero movies and stuff, where the guy's like dressed in like a green?
Oh, the dots on them?
Yes.
Oh, yeah.
Okay. The green dots are for these transformations, for when they grow things or shrink things. Okay, if they grow or shrink it, they need to make sure that the proportions are accurate, so that it doesn't make his arms really long all of a sudden, or his face look distorted. So they measure and make sure that if they're getting it, growing it or shrinking it, that the proportions are the same from the nose to the forehead, from the arms to the like from shoulder to the arm. Okay, they want to make sure that those are all the same, and it makes it easier if they can program it into the computer and have the computer do it instantly, so they don't have to redo it every single time. Because those very first animations of Disney's, like Snow White and all that stuff, that was all done by hand. Now we have some amazing computers that can do it all for us. Okay, and makes it grow and shrink. And that's what this whole thing is about. That's how they use it in real life. Okay, translations are also can be used in animation and to make a character move, walking, talking, things like that. They'll use a translation. Okay. Translation is a term used in geometry. I currently am. To describe a function that moves an object a certain distance. In a translation, every point of the object must be moved in the same direction and for the same distance. Along parallel lines. Okay, you guys saw this last year in Math 1. We're going to try it again, just make sure you remember how to do it. Okay. So translation is just taking each point. So when we're talking about those green dots, taking all those points on the person's body and moving them all in the same direction at the same time. So we're going to start with point B. We're going to take point B and translate 6 units down and 4 units to the right. So we're going to go down 1, 2, 3, 4, 5, 6. And then to the right, 1, 2, 3, 4. And that's going to be our new point, B prime. We're going to do the same thing with C. I'm going to move it 6 units down. So 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4. And that's going to be our C prime. Same thing with D. 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4, 3, 4. Almost went too far. D prime. Then we're going to move A down 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4. And that's A prime. So if you notice all of these lines, so A to this right here is parallel to the red line here. The green line is also parallel to it, and the blue line is also parallel to it. Those are all parallel lines. Okay, same with the horizontal distance from here to here, from here to here, from here to here. Those are all parallel lines. Okay, they're moving on parallel line paths. Now, if I graph or I connect these dots together from A to D, A to D prime. Okay, what do you notice about my figure now? Yeah. What do we notice about the first quadrilateral and the second quadrilateral that I graphed? They're the same exact shape, just in a different location, right? I just moved it to a different location. But those are congruent shapes. That last line doesn't look so great, but I'm not graphing it well. It's connecting the dots very well. But those are all, that's how will always be. You'll just take the same shape and move it to a different spot. And those are going to be congruent figures. Any questions over that? Okay. A reflection is a mirror image across a line of reflection. If you connect the corresponding points on the image and the image, then the line formed is perpendicular to the line of reflection, and they are equal distance from the line of reflection. So this is my line of reflection right here. If I fold my paper along that line, it'll have that image reflected across. Okay. We can write the equation of the line of reflection. We just need the slope and the y-intercept. So it crosses the y-axis here at -1. And we can find the slope just by rising 1 and running 1. It's going up 1 and over 1, so it's a positive slope of 1. Any questions over that? So the equation of this line is just y equals, we can have 1x, but we don't need the 1x, and then -1. And that's the equation of that line of reflection. Any questions? Then it also says that if I connect the pre-image and the image points, so that's if I connect C to C prime, that line that I created, this line right here, the blue line, is perpendicular to the line of reflection, and it is congruent on either side. They're equal distance. So C and C prime are equal distance from the line of reflection. And that's true with all of the points. So if I connected D to D, that would also be perpendicular. That's a bad perpendicular. Perpendicular and congruent. Any questions over that? Rotation. Okay, a rotation is a transformation in which a plane figure turns around a fixed center point. In other words, one point on the plane, the center of rotation is fixed, and everything else on the plane rotates about that point by a given angle in a clockwise or counterclockwise direction. So here is our center of rotation. Was -2 and 1. The center of rotation is -2 and 1. And what's the angle of rotation? Anyone see the angle at which we rotated? 90 degrees. If you connect here a line from the center to the image, and also then to the pre-image, you can see that that's a 90-degree angle. So that's why it's 90 degrees. Okay, and the image is rotated 90 degrees. The rotation, you'll have equal distance from each figure. So this will be congruent to this when you rotate it. If you draw a perpendicular line to the image and then to the pre-image. Any questions on that? Okay. Dilations, which we just talked about. This is new. You did not talk about this last year. Okay, dilation is a transformation that changes the side of the figure. It can become larger or smaller. But the shape of the figure does not change. To complete a dilation, two things are needed. The first is a center point or a fixed point, which is usually only mentioned when the dilation must be drawn. So you won't talk about it unless you're actually drawing it yourself, and you'll see that in the homework. The second is a scale factor. Or ratio, which is often represented by the variable r. Okay, so here you have parallelogram ADCB is the image where we started as. So the smaller figure is where we started. Okay, then parallelogram A prime, D prime, C prime, D prime is the pre-image. Then what do you notice about the two figures? Write it down, please. So everybody writing something down right now. Okay, it is.
The pre-image is a double size of the first.
Okay, correct. The pre-image is double the size of the image. And you can see that right here. This is 3 units long. Then A prime B prime is 6 units long. So that's double the size. Okay, that would also mean the scale factor is 2. And we also call the image and the pre-image similar figures. Parallelogram A, D, C, B is similar to parallelogram A prime, D prime, C prime. Any questions over that? Okay, now in the next one, we need to identify the scale factor and find the missing angle. So we're going to start by labeling these. I should have labeled this in the notes to begin with. This is what we're going to call the image. This is going to be the pre-image. Okay, so label them for me, please. Okay, we then want to identify the corresponding parts. So here is 4. On the pre-image, what corresponds to the 4? The 8. That makes sense. Because it's the same line. This is just increased by some sort of factor. And we'll get there. Then the 3 corresponds to what? On the bigger 6. And then finally, the 6 and my unknown. Very good. Most of you guys can come up with x should be 12. Because you can clearly see that 4 is just doubled to get the 8. The 3 is doubled to get the 6. So I have to double the 6 to get this side, which is 12. Okay, but they also want the scale factor. So I wanted to show you how to do that. The scale factor equals the pre-image over the image. So you put one of the sides for the pre-image over the corresponding side of the image to get the scale factor. It doesn't matter which one we use, because if I use 6 and the 3, I'd still get a scale factor of 2. So my scale factor here, here's my image of 6 over, sorry, that's my pre-image of 6 over my image of 3. So the scale factor equals 2. Any questions over that? Okay, now the next one, it's not as obvious. It's not as easy to see what x is going to be. So I'm going to show you how to do that. So again, we just want to make sure that we know that this is the image. And this one's going to be our pre-image. We want to know our corresponding sides. Brandon. Okay, what corresponds to 8 in the pre-image? Oh, thank you, Brandon. Okay, so that's how we're going to find the scale factor. Equals the pre-image of 6 over the image of 8. And then we reduce that and we get 3 over 4. So this is my scale factor, 3/4. Any questions over that? Okay, now we're going to find x. In order to do that, we know that they have the same ratio, that they're shrinking. In this case, we're shrinking instead of stretching. So we write a proportion. We do the scale factor of 3/4 equals, we have to have the corresponding sides go with each other. So we want the pre-image on top, so the x goes on top, over, sorry, over the image, which is 6. And you're gonna cross multiply. 6 times 3 is 18. And then 4 times x is 4x. You're going to divide by 4, divide by 4. And you're going to get x equals 4.5. Any questions over that? The key here is you need to make sure you're lining up your sides. That you're not saying that 8 goes with the x. Because 8 is clearly not the same as x in my smaller figure. Those are not corresponding sides. Does that make sense? Okay, so I want you guys to try C on your own. Okay, so back up here, guys. We need to start by finding the scale factor. And remember, your scale factor is the pre-image, so we need the 12, over the image, which is 10. And so that should reduce to 6 over 5. You cannot have 5 over 6 and be right. That's incorrect. That is not the correct scale factor. Okay? You can, however, use 5 over 6 to solve it. Okay? And that's fine. I don't care how you solve to get x. But if I'm asking for the scale factor, you need to make sure you're putting it like this. Okay? So then I just set up my equation. 6 over 5 equals my corresponding sides of x and 4. Then I'm going to cross multiply. That gives me 24 equals 5 times x, which is 5x. Divide by 5, divide by 5. And that's going to be x equals 4.8. Any questions over that? Okay, now in your homework, they're going to ask you to dilate the following figure with the given center and the given scale factor. Okay, you're going to want to use a straight edge, a ruler, somehow to do this. Okay, because you need to measure distances here. So if you've got math money right now, you can use your math money. I'll show you how to use math money as your measurement, way of measuring. Okay, make sure you put the point as M. I don't think it's in your notes, so just label it M. We're just labeling it a letter. We want the scale factor of 2. So I want to start by drawing lines from my center point to the vertices. Okay, so just draw straight lines from the center point to each of the vertices of my triangle. Then you're going to measure the length from M to A. So if you're using your math money, just line up one edge of it to the other and then mark the length there. Does that make sense? So now I have the distance from A to M, or M to A. And because I want to make it a factor of 2, a scale factor of 2, I want to make it twice as big. I want the length from M to A to be twice as long. So this is 1 of it, this is 2 of it, and I'm going to mark that line there. So I'm gonna do that here. You'll see, don't worry, don't stress. Okay, so I'm gonna draw that line again from M to A. And I'm just going to add it on because I want it twice as long. And that's going to be A prime. Any questions over that? I'm going to do the same thing with M to B. Measure that distance. And just add it on to the end. And it's going to be B prime. Then do the same thing with M to C. Measure the distance from M to C. And just add another one onto it. This is C prime. Any questions over that? Is everyone there with me now? Now we're just going to connect those dots to make my new triangle. Now about a ruler, I can measure that AB was half as big as A prime, B prime. Or that A prime, B prime was twice as long as AB. Does that make sense? Again, all the angles are congruent on here. So A prime and A are congruent angles. B and B prime are congruent angles. The length of the sides, though, each corresponding length of the sides is going to be twice as big as your original figure. Any questions over that? Okay, now we're going to do a scale factor of 1/3. Okay, so we're going to start the same steps. I'm going to draw a line from M to C. Okay, connect all those from M to all the vertices. And then look at me when you're done so I know you're done. Okay, so this is gonna be a little bit more difficult because we have to not increase it by a length, we have to decrease it, okay? We need to decrease it to 1/3 of it. So we need to measure 1/3, okay? Give me 1 second, I'm gonna show you how to do that with your.